Today we're going to do a review over the material that you may see on your final exam. Your final exam is going to cover topics that we have covered since the beginning of digital learning. Remember that your final exam is worth 10% of your overall grade. So please focus this week, make sure that you are doing all of your review work, and make sure that you are logging on to any help sessions to ask questions. All right, so the first thing we covered during digital learning was circles, and we talked about area and circumference of circles. If you look at the circle on your screen, you notice that there is a measurement of 5 inches. Well, this length goes from the middle of the circle to one edge. That means that this is the radius of the circle. So the radius of this circle is 5 inches. Now the diameter is the measurement that would go from one length through the middle all the way to the other length. So in this case, the diameter would have been twice this amount because it would have gone all the way through here. So it would be 5 inches here and 5 inches here, or the diameter would have been 10 inches. Now we're going to use what we know about this circle's radius and diameter to find its circumference and area. Remember, circumference is the distance around a circle. It's kind of like perimeter, except that because the circle doesn't have any sides, we can't add side lengths. So the distance around is circumference, and the formula for circumference is pi times diameter. So to find the circumference of this circle, we're going to use 3.14 for pi, and then we're going to multiply that by the diameter of the circle, which is 10. When I multiply 3.14 times 10, I get 31.4. And I always need to put my units of measure here. So my circumference is 31.4 inches. Now I'm going to find the area of the circle. So to find the area, I always do pi times radius squared. So it's going to be 3.14 times, and I found that my radius was 5, so times 5 squared. Now the order of operations tells me that I would always do my exponents first, so I would need to do 5 squared, and 5 squared means 5 times 5. So 5 times 5 gives me 25. So to find my area, I'm actually going to do 3.14 times 25. Now, when I multiply 3.14 by 25, I get 78.5. Again, I need to always have my units of measure. So this circle was measured in inches, and area is always measured in square units. So this is going to be inches squared. Now let's look at another circle. This circle has a measure of 12, and that measure goes all the way from one edge to the other. That means that 12 for this circle is the diameter. So 12 inches is our diameter. Now I can use that to find my radius. If I know that this is my diameter, my radius is only half of that length. So to get my radius, I would do 12 divided by 2, and I would get 6 inches. Now I'm going to use my radius and diameter to find my circumference and area. So circumference is pi times diameter. So in this case, pi is 3.14 times my diameter of 12. So when I do 3.14 times 12, I get 37.68. And again, I always put my units. So in this case, I'm going to put inches. Now area is pi times radius squared. So it's going to be pi 3.14 times my radius I found was 6 to the second power. Again, I do my exponents first. So 6 to the second power means 6 times 6. So I do 3.14 times 36. Now when I multiply 3.14 by 36, I get 113.04. Again, my units of measure are inches, and because it's area, I always have square units. So my area is 113.04 inches squared. Now let's look at triangles. So we talked about triangles and the side lengths of triangles, and that was the triangle inequality theorem. That theorem said that when I add any two side lengths, they must be greater than the third side length. So what we always did was we chose our two shortest sides. So in this problem, I have 4, 6, and 7. Well, my two shortest sides are 4 and 6. So I'm going to do 4 plus 6, and they should be greater than 7 for this to make a triangle. Well, if I do 4 plus 6, I get 10. And then I need to ask myself, is 10 greater than 7? Well, yes, 10 is greater than 7. So because these two side lengths added together give me a number that is greater than the third side length, then yes, these create a unique triangle. Now our next side lengths are 8, 12, and 3. So I'm going to find my two shortest side lengths, which are 8 and 3. So I'm going to add 8 plus 3, and they should be greater than my third side length, which is 12. Well, when I add 8 plus 3, I get 11. So is it true that 11 is greater than 12? Well, no, that's not true because I know that 11 is actually smaller than 12. So since that's not greater than 12, these side lengths will not create a triangle. Now let's look at 9, 15, and 6. My two shortest sides are 9 and 6, so I should be able to add 9 and 6, and if these make a triangle, then that length will be greater than 15. Well, if I add 9 plus 6, I actually get 15. And then I need to ask myself, is 15 greater than 15? Well, no, 15 is not greater than 15. 15 is actually equal to 15. So because that number is not greater than this one, these side lengths will not make a triangle. Let's look at 15, 4, and 13. So my two shortest sides here are 4 and 13, so I'm going to add those together, and they should give me a number that is greater than my last side, which is 15. If I do 4 plus 13, I get 17. And now I have to ask myself, is 17 greater than 15? Well, yes, 17 is greater than 15, which means that these three side lengths will make a triangle. And now let's look at our last problem. We have 9, 18, and 13. So my two shortest sides are 9 and 13. So I'm going to add those together. And if it makes a triangle, then it's going to be greater than my third side, which is 18. When I add 9 plus 13, I get 22. And now I have to ask myself, is 22 greater than 18? Well, yes, it is. So that means that these three side lengths will create a triangle. Now we're going to look at the next thing that we did for digital learning, which is talking about angle measures. So we talked about complementary, supplementary, and vertical angles. Complementary angles are angles like these, where you have a right angle or an angle that measures 90 degrees that is split into two different angles. If I need to know what x equals, I need to think about what I know about the whole thing. I know that this whole thing is equal to 90 degrees. And if this angle is 82 degrees, then to find x, I'm going to take my 90 and subtract 82 from it. When I do 90 minus 82, I get 8. So that means for this problem, x is 8 degrees. Now for this angle, I notice that I have a straight line. A straight line has a measure of 180 degrees. That means that these two angles that are created from this straight line are supplementary to each other, because if I add them together, I should get 180. Now, since I don't know what this angle equals, I'm going to subtract 146 from 180. Now, when I subtract 146 from 180, I get 34. That means that x is equal to 34 degrees. Now for these angles, I notice that I have two intersecting lines. And when I have two intersecting lines, I know that those will always create vertical angles. Vertical angles are those angles that are across or opposite from each other. In this case, x is opposite from 45 degrees. That means that these two angles are vertical. And what I remember about vertical angles is that all vertical angles are congruent. So if this angle is 45 degrees, then this angle is also 45 degrees. That means that the value of x is 45 degrees. Now we can use all of that information to find other variables. So let's look at this problem. In this problem, I have intersecting lines, which means I create vertical angles. Well, if I know that I have vertical angles and I know that this angle is equal to 140 degrees, then the angle that is opposite of it is also 140 degrees. Well, that angle is z. So I know that z has a value of 140 degrees. I also know that x and y are vertical to each other. So if I find either x or y, then I know the other angle because these two angles are going to be congruent to each other. So I'm going to think about what I know here. I know that each of these is a straight line, and every straight line has a measure of 180 degrees. I know that right here, this 180-degree line is split into two angles. It's split into x and 140. So if I need to find out what x equals, I'm going to do 180 minus 140. And when I do 180 minus 140, I get 40 degrees. So that means x equals 40 degrees. If x equals 40 and it's vertical to y, that means that y also equals 40 degrees. So in this problem, x is equal to 40, y is equal to 40, and z is equal to 140. Now for this one, again, I have an angle here that's 49 degrees, and it is vertical to z. So that means that z has a value of 49 degrees. Now, if I need to find x and y, I notice that x and y are vertical to each other, so they have the same measure. And I need to figure out what one of them equals. So again, I see that there is a straight line which has a measure of 180, and this creates two angles out of that 180 degrees. So to figure out what y equals, I can do 180 minus 49. And when I do 180 minus 49, I get 131. That means that y has a value of 131 degrees. And if y is 131, I know that it's vertical to x, which means these two are congruent. So x also has a value of 131. For this next problem, I have two intersecting lines and I have vertical angles. I know that this angle is congruent to this angle. If I need to find the value of x, then what I know is that 2x plus 6 is also equal to 96. So I can write an equation that says that 2x plus 6 equals 96. And now I can solve my equation to solve for x. I can subtract 6 from both sides of my equation. These would cancel and leave me with 2x. If I do 96 minus 6, I get 90. Now I'm going to divide by 2 on both sides. Those would cancel and leave me with x, and 90 divided by 2 is 45. So the value of x here is 45. Now the last thing that we looked at during digital learning was exponents. So we're going to talk about some exponent rules. In this problem, I have 5 to the third, x to the second, y to the fourth, times 5 to the fourth, x to the fifth, y. I see that I'm multiplying, which means I need to use my product rule for exponents. The product rule for exponents said for me to add the exponents of like bases. So for this, I have 5 to the third and 5 to the fourth. I'm going to take the exponent of 3 and add to the exponent of 4. So I keep my base of 5, and now my exponent becomes 7 because 3 plus 4 equals 7. Now I'm going to look at x. This x has an exponent of 2, and this x has an exponent of 5. If I do 2 plus 5, then I get x to the 7th power. And finally, I'm going to look at y. This is y to the 4th and y. So if this y, even though it doesn't have an exponent, I know that there's an invisible 1 here. So when I add my exponents, I'm going to add 4 plus 1, which gives me y to the 5th power. For this problem, I see that this is written as a fraction, which means this is a quotient or a division problem. When I divide with fractions, I always make sure that I subtract my exponents of like bases. So for this problem, I have x to the fourth over x to the second. I'm going to take my exponent of 4 and my exponent of 2, and I will subtract 4 minus 2, and that gives me x to the second power. Then I have y to the seventh over y to the second. I'm going to take my two exponents and I'm going to subtract. So 7 minus 2 gives me y to the fifth power. Next, I have 12 to the fifth, a to the ninth, b to the fifth, times 12, a to the third, b. This is multiplying, so I'm using the product rule, which means I'm going to add my exponents. So I'm going to start with 12. This 12 has an exponent of 5, and this 12 looks like it doesn't have an exponent, but we know that it has an invisible exponent of 1. So I'm going to do 5 plus 1, which gives me 12 to the sixth power. Then for a, I'm going to look at my exponent of 9 and my exponent of 3, and I'm going to do 9 plus 3, which gives me a to the 12th power. And finally, I'm going to look at b, which has an exponent of 5, and this b has an invisible exponent of 1. So I'll do 5 plus 1, which gives me b to the sixth power. This problem is written as a fraction, so I know that means that it is a quotient or a division problem. So I'm going to start by doing 5 to the sixth over 5 to the third, and because it's dividing, I'm going to subtract the exponents. So 6 minus 3 gives me 3, so this will be 5 to the third power. Now I have a to the seventh over a to the seventh. Well, if I do 7 minus 7, that gives me a to the 0 power. And then I'm going to do b to the ninth over b to the sixth. If I do 9 minus 6, I get b to the third power. Now it looks like I'm done here, but I'm actually not, because if we remember, if we ever have a number that is to the 0 power, that actually equals 1. And if I'm doing 5 to the third times 1 times b to the third, then this actually just sort of cancels out. And what I'm left with is 5 to the third, b to the third. All right, for my last problem, I'm going to do 9hjk times 9 to the third, j to the seventh. This is a product, so I'm going to be adding my exponents. So I'm going to start with 9. This 9 has an invisible exponent of 1, so I'm going to add 1 to this 9's exponent of 3, and that's going to give me 9 to the fourth. Then I have h. I notice that h doesn't have a variable over here, so I'm just going to have to rewrite it the way that it is. And then j, which has an invisible exponent of 1, and this j has an exponent of 7. So 1 plus 7 is going to give me j to the 8th. And then I have k. Again, k doesn't have an exponent over here, so I'm just going to rewrite it the way that it is. Finally, we're going to simplify some exponents that just have numbers. In these cases, I can just multiply these like I would normally. So with negative numbers, we have to be very careful because this says negative 5 to the second, and this also says negative 5 to the second, and they look the same, but they're actually very different. In this problem, this is saying negative 5 in parentheses to the second power. That means that I'm taking negative 5 and I'm multiplying it by itself twice. Well, if I do a negative times a negative, I know that that gives me a positive number. So negative 5 times negative 5 gives me positive 25. Now in this case, this one, it looks similar, but it's a little bit different. In this case, the exponent of 2 is on the 5. And this is saying I'm going to take 5 and raise to the second power, and this negative on the outside tells me that I need to know the opposite or the negative value of that. So this is telling me to do the negative of 5 to the second power. And 5 to the second power is 5 times 5. Well, 5 times 5 is 25, but this tells me that I need it to be negative. So this would be a negative 25. In this problem, I have negative 8 raised to the second power. Because the negative is inside the parentheses with the 8, this is telling me that I'm raising that whole number to the second power. So I'm doing negative 8 times negative 8. And when I do negative 8 times negative 8, I get positive 64. In this problem, I'm only raising the 8 to the second power, and the negative tells me to tell the opposite of that value. So this is telling me to find the opposite of 8 to the second power. Well, 8 to the second power is 8 times 8. So this is telling me to do 8 times 8, which is 64. But this tells me to find the opposite of 64, which is negative 64.